Okay, on number 2, it's not ready to graph yet because it does not flow in slope-intercept form where the equation goes y equals mx plus b. So in your journal, behind where you will end up gluing this one, you want to go ahead and write out these 2 equations. So pause it now and write these in your journal. Okay, so that below it, you can solve it. So I'm going to bring down that first equation, x minus 3y equals 2, and above it, I'm going to write that my goal is y equals mx plus b. So the y is in the correct spot if I'm lining up the equals, but this x term needs to be clear on the other side of equals. So since it's a positive x, you need to do a negative x to help this one cancel. I'm going to bring down what is left in the equation. So I have a negative 3y equals, remember whenever you're looking at these 2 terms, you want the x term to go first. So I'm going to take this number that was here, that positive 2, and I'm going to push it to the back of the equation. Okay, so now it looks a lot more like my goal because y is on the left side of equals and x is on the right side of equals. But I don't want this negative 3y to be, I don't want the negative 3 to be a coefficient on my y. So since they are multiplying, I had to divide everything by negative 3 because negative 3 divided by negative 3 will cancel. So I have y equals, if it doesn't have a number, you give it a 1. So this is a negative 1 over negative 3x plus 2 over negative 3. I can simplify that to 1/3 x minus 2/3. Okay, so that is the first equation that we will be graphing, but I'm going to go ahead and rearrange that second one. Okay, so that second one said negative 3x plus 9y equals negative 6. You want to write your goal above it. We want it to be y equals mx plus b so that it would be easier to graph because I need to see the b number and I need to see the m number. Okay, this x term is on the complete wrong side of the equation. This is negative, so I'm going to give it a positive 3x so that this can cancel out. I'm going to bring down what I have. 9y equals, I want the x term first. This was a negative 6, so I just push it to the back. My y is in the correct spot. My x is on the correct side. I don't want the 9, so I'm going to divide since they were multiplying 9 times the y. 9 divided by 9 is just 1, so I'm just left with that 1y, but you don't have to write the 1. I put this first part over 9. I can bring the x out behind it. You can put a plus here. So this last term, this negative 6, is going over 9. Then all that's left after you break up those 2 parts is reduce it. So 3 over 9, those will both divide by 3 to leave me with 1/3 of x. Negative 6 over 9. It's going to give me a negative answer, so I'm just going to put minus. They both divide by 3 to leave me with 2/3. Okay, now back on the note page, I'm going to write these 2 equations that I got. I got y equals, the first one said 1/3 x minus 2/3. The next equation, whenever you rearranged it, it said y equals 1/3 x minus 2/3. Wow, what do you notice about those? Maybe they're the exact same equation, so whenever I graph them, I really only need to graph one line because whenever I go to graph the second line, it's going to be a line on top of a line. Okay, now this one's a little bit tricky to graph because my y-intercept is a negative 2/3, and this graph is counting by ones, so you're going to have to be pretty specific. But that number at the back tells me where to start graphing on the y-axis. So I'm going to go and estimate the best that I can a negative 2/3, which is in between a 0 and a negative 1. It's a little bit closer to the negative 1, okay? Now, whenever I rise a third, I'm going to go up a whole unit from where I am, and then I'm going to run 3 units to the right, okay? Because remember, the M number tells you how to move, rise over run. So from here, I'm going to go up a unit and over 3. 1, 2, 3, put a point. Then I'm going to go up a unit and run 1, 2, 3 to the edge of that graph. Go ahead and use a ruler to draw that line. Put arrows on the ends. Okay, so these two equations were exactly the same. So I don't really want to graph another line on top of this one, but remember that for systems of equations, they're wanting the solution, or they want the point where the lines meet. So this first set of lines only had one solution because it's crossing at that one spot, 3, 5. So if I have a line on top of a line, think about how many solutions it would have. It wouldn't just have one point. It has an infinite number of points because this line is going on in both directions. So infinite number of solutions.